All right, I believe we are live. Just checking the sound and everything. I believe everything should be just fine. So let's see here. Oh, that's cool. I'm just looking at some settings for my streaming. I will be back in. All right. Well, welcome back to the City Builder, where today we're going to be looking at pathfinding. And I asked ChatGPT to give me some hints on it because I'm going to be using the A-star algorithm for this, and I wanted to make sure that I approach it in the correct way. And of course, you should not always listen to what ChatGPT says, but just to get some inspiration for an approach. All right. And so, what we're going to do today, we're going to do this A-star pathfinding. And I believe I made some notes as well. Oh, here. So we're gonna um let me just sorry for 1 second. I need to do something else. Okay. So we're going to be adding these functions: path, add node, add edge, find, and that is because in when we add these paths, when we add the roads, we want to make sure that we can calculate the correct distance. So, all right, let me just get into it here. Let me see. Perfect. All right, so let's start by looking at our road network, okay? So for now, the road network is just an array of object roads. And let's see, so let's just try to run the game and explain it from a different kind of perspective. So now we have created a road, right? We have created a road with two lanes, one node here, one node there. And then we have created one there as well. So for each node, these nodes, they know what roads they're connected to or lanes they're connected to, right? So we need to make sure that they know exactly the lanes. I'm gonna go check that. I believe they know the lanes. So let's see here in node, create. It's roads actually. So because we want to do a multi-directional roads with lanes and stuff, I believe the best way to do this is to change this to lanes. But for now, we will just to make sure we don't ruin anything. We will just make another one called lanes here. And perhaps at some point they want me to change this into, or at least the one in here, into like a DS list, so we can do some. Um, to get some. Let me see. So let me just think for a second because so we have the roads when these are created. So they just, but is there anywhere else where these are addressed? The nodes and the lanes, right? So we have a lane here, which is basically just an object that has a start and an end position. Because that is very simple. Then you have the direction implied, right? So that makes a lot of sense. With the object road itself, right? So this has lanes. And perhaps I was thinking that I should address the lanes through the roads, and perhaps I will do that. Let me keep looking here. So we have the set geometry. Yeah, I remember this. So we just, yeah, we're saying the geometry. It makes perfect sense because we want to have the collision masks, and we are utilizing the built-in game maker collisions for this. That makes a lot of sense. I guess, are we doing anything? This I don't know. It seems like a janky solution for sure. Mm. Alright. So the next step is to have all of this. We want to have all of this combined, right? So like a pathfinding mechanism. And we have to be very careful when we start about this because we want to do as few calculations as possible at a time and still have the game run smoothly, right? Um, and there are a couple ways I was thinking of doing this. Okay, so all this is pretty ugly. Let's just open a new one here. Okay, so we have a pathfinding mechanism. Actually, let me. No, I don't. I don't want to be that guy that goes into pain and starts explaining. Um, pathfinding. Okay. So the A plus, A star, sorry, the A star algorithm basically uh, looks at like a rough estimate at each iteration. It's kind of, I don't even know how to explain it. It takes a pretty long time to explain it. I just saw some videos on this earlier, and then you can definitely find it on, I think Computer File made a pretty good video on it. Um, so let me just write that. A star, this is the algorithm that we, at least we're going to take inspiration from, okay? Um, and so we need to have and what I was thinking, what we could do, even though that seems probably unnecessary, let's just a simple scenario. Okay. Uh, find best path when create. I mean, yeah, I guess that makes the most sense. Just find best path when created and follow that path, right? And so we have initially we have this vehicle pedestrian that does these things, and perhaps we should just have the vehicle class itself do the pathfinding. at least for now, because that's the best way that I can see like a direct solution to it right now. Then we can always change it to have a different kind of handling situation later. But then we can at least uh, expand it to cars that can work on different kind of paths later on. We are already here measuring the distance to the target, right? And so what we're going to do is we're going to go in here and set a sub-target. And perhaps we will already make a path. And because GameMaker already has a path mechanism, we're going to call this a path for a star path or AS. I believe we can just do it like this, and then it's just named array for now. And so what we want to have happen is, let me see, is there anything in this one? Passengers capacity. Okay, that's fine. So let me see here. So when we start this, we want to, or actually we'll already here, or where is our target set for the pedestrians? Is it set in the demand handler? I would assume so, right? Yeah, target, exactly. So set in there, and we'll go back into the pedestrian. We'll go into the step event here. Right? Um, so what we'll do is we'll take this and put it in here. So if there is no sub-target, we'll just do the traditional method. And you know what I'll do? I'll start writing some comments on this. So stand still if no target. Okay. If target with no sub-target, walk straight to straight. Or actually, if no sub-target, we're going to, in here actually, I think we should set the sub-target set. Because then we can later on ask the we can ask, let me see here, sorry, I'm a little bit all over this, it's okay. Let's go here, so sub-target, we can move towards the sub-target, and for the sub-targets, because they're nodes, we would actually probably have to increase this a little bit. Okay, let's try and see here. So sub-target, then we say instance nearest me node. And then we should probably also set some other things here. So that current Uh, lane, perhaps. Yeah, I feel like lane would be the best thing to go about. Yeah, we have to do that. Then we can do like a double, like we already are doing now with the ropes, and it will make it easier for us to make one directional paths. So I still like this functionality that we can start from absolutely nowhere. We don't need to have a road that comes in. We can just have people walking in. It might be a little silly, but I think it's fun concept in itself. So we'll start with that at least, and then perhaps later we can have them come by. I mean, they have to when they come by car, right? Okay, so then we'll do something like this. So when we are, if distance else, we will remove the sub target. Okay, and maybe we'll do something with like take the next one dot pop. I believe there is some kind of function for that, but I don't know yet. We'll just set it like this for now. Um, so I'm curious what will happen. We can just see what will happen now. I don't think anything that crazy will happen, but let's see here. So we have road, and then we can create a house here. Boom and boom. Let's see. Now some people will come. Hmm, this guy is just going straight to the house. Okay. Maybe he saw that that was better. No. So everybody's going straight to the house. That's very interesting. Maybe I just probably said something wrong in here. And oh wait, I see. So yeah, there we go. I forgot to change the target of where it should go. So the target itself is the final target, and I will actually uh, write that here. Target is final target. So target is next node on path. Okay. Now I went in there. So it goes to the closest node first, and then it goes straight afterwards. Right. That's also what we can expect because it goes to its first sub target and then it goes to its next, to its final target. And so effectively, what we want to have happen is that we in here, if we have no sub target, we we look into this. You know what? I'll just set it as a ds list create already now. 'Cause I'm pretty sure we're gonna have to do this at some point here. Either way, so what's the next one? Sub target. So we have to look at this as path. and I will just I can share with you my window here. So maybe we'll just go here, look here. So we'll have some DS lists. And see, already now this we can think of this as a it can become a problem because if we start to have perhaps 1,000 pedestrians, they all need to have lists all over the place. And at some point we have to probably change into some kind of map structure. But let's keep it, let's say that we stay within like 100, maybe even just 50 people, until we get to a larger scale. Do uh, we can do some a little bit simpler options just to get some things going here. So I just wanted to see what kind of um, perhaps is something. It was actually a priority queue. Yes, they use priority queues in the A star algorithm. And so, yes, exactly. So what I want to have happen is that they calculate their path either when they get to the first node. So that will be here, right? So that will be here, right? So if we create a priority queue or priority queue, we can say here, okay, add. Let's just see here, okay, and then we can see. Let me find the okay, okay. So we make a priority list or priority queue. Okay, this thing is going to be used to we can add these priorities or these yes we can add the values with the priority, and that's exactly what we want to do so that we every time um, we look through the map, we can like prioritize the one that is the closest already, and so we get a rough estimate first, which makes this algorithm more efficient. And so basically what we want to do here is to say, or actually what we want to do is we want to create a script that says, okay, script find path. I'm just gonna see if I can, yes, there we go. And so, and we can just put this in here for now. Before we do anything else, we should make sure to have this is the first, so we define a start node, end node. And then we at least start node should be subtarget and end node should be target. Even though target going to be, is target the node? Let me see. I need to make sure that they're both nodes of the object node. Uh, all right. And so then, so let's see, when we make the houses, it's, it's in the demand handler, yeah. Yeah, so actually here it should not be the, yeah, let's just do it like this, actually. I feel like this is a more soft, safe solution. So what we're looking for here, so what we're looking for is, so they're first going to the node. Okay, yeah, well, they're still absolutely disregarding the, all right, let me just go, so when we go from the node, from one node to the next node, we start by looking at the node that this one is connected to. And this is earlier we created this one called lanes, but we're not actually using it. So let's just, for now, try to make the solution work with only with the roads themselves. So then we access the roads and then we access the lanes within the roads. And perhaps we could actually do something even simpler right now that says that's just a recursive function. But let me just try and do something here. So this priority queue is going to be filled with new nodes that we're going to look at with some new paths in them and some distances as well. That's how I understand it. Just do this. So there's a okay. So and I think what I'll do actually is yes, make these make like a nice. There we go. Um, so sorry for me being silent. I was thinking a lot. So for the next situation, we're just looking at if there's exactly one road connecting to the node. So it's just a one lane or one road that goes to some other node. Then it's pretty simple. We get the other node. So we have go into the road here, nodes. So for a road, there should always be exactly two nodes and two lanes. Or not necessarily two lanes, but always two nodes exactly. So they're road segments, right? Perhaps we should change the names of later. But so we know for roads always have two nodes. So we can just look at both of them and just say the one that's not the one we're looking at. Okay, so start notice here. Um, there we go. I'm gonna add, or is it what is it push to the final path. I don't know if this is probably not the right way to do it right now, but that's what we're going to do. So if we push it, no, that should not be how we do it. I can't write it either. Today, that's really great. Okay, so we're adding to the final path the different nodes. I'm also thinking at some point that we need to like save the most commonly used routes or something like that to optimize. It's a bit hard for me to do the programming right now because I'm thinking so far ahead because this is a pretty big deal and it's going to take more than 2 days to get started properly. So perhaps instead of just saying, hmm, so let's just okay. So uh, citizen is I would say pedestrian is created, then let's go say pedestrian. P defines closest node. Okay, walks to closest node. I would love for it if it could happen at the step event where like here as P walks to the closest node. Um, SP, SP walks to the closest node. Cal calculate best path. I was also thinking about doing something different where, the people themselves will just kind of figure it out themselves or like walk, not randomly, but just look like, and you know what? Perhaps that is actually what we will do. So we will just find the node, take the node that has the closest Euclidean distance to the end node. So, so we will effectively just return one new subtarget. And so I think we will duplicate this and call it find new subtarget. Okay, so let's just get it out of here and go into this one again. And we will open both these here. So here we're running this path, and actually it seems actually a bit unnecessary. A couple of things is that also we don't need the every citizen to walk the best possible path every single time. And I think making a simpler solution for now is only going to accelerate the production of this game as a whole. So what we're going to do instead is that we are going say here if subtarget is equal to -1, subtarget is equal to um, find oh find there we go. Um, Actually, yeah, let's have a current node, a current lane, and a current node. Okay, and so current node is equal to subtarget. So now the value gets replaced, right? And so here we then say if current node is not equal to -1, and then we can say then we have the current node and then find our target. That makes total sense, right? And then the sub-target will be a very simple solution where we look at each node that we're standing at, right? Or we look at each road that this is connected to, that's not, the world where we just came from. Um, and then we look at some distances. Okay, let me see here. Do we have any? Yeah, road length. Great. We can actually calculate the road length here. And is it scaled in any way? Let me see here. Road length. Okay, so it's scaled by 16. Great. Yeah, so it's by number of pixels in it. Makes perfect sense. All right. And so the next step would be to, let's see here, look here. If the array length is 1, okay, so find new subtarget. Let me say here, instead of, yeah, we're not going to do this, and we're not going to do this. We are just going to return. Because this, in this way, we can actually extend it to a more A-star-like algorithm that updates itself dynamically. Right, and then we can do some really cool things with this later. But if we can keep this really simple and let people kind of figure it out. Let's see if people actually find the way home. That'll be very interesting to see. Okay, so let's see here. So if there's exactly one, then we need to see if there's exactly no, and then we just say if there's more than one, right? Just so good mission stuff. So if there's zero, then well, then something's wrong. Then we don't deal with it right now, right here at least. Hmm. So here now we can start looking at the each nodes. Okay, so we're trying to make a for each loop, uh, like so. Actually, we're gonna say bar length or row. No, wait a minute. All right, yeah. So we only calculate this once. This is just a nice little. And then we say here as well. All right. And again here, we're going to say var smallest index is equal to -1, right? And then we're gonna say for each for each road, where the node that it goes to is that closer to our final target. Okay, so we're just gonna write that for each road, does it lead to a smaller Euclidean distance? Take or to randomize it a little bit, we're going to say choose between two smallest between two nodes with distance to a target. That was a bit much. I didn't expect to have to write that big of a node. Let me just increase this a little bit. Okay. So what's the next step? Next step is to flesh this out. So rows. This is the current node, or current road that we're looking at. I'm gonna write here index of small of. No, you know what? Actually, I don't think we are. Are we gonna do that? Okay. So so we're looking at road var r, we just call it, is equal to this. Okay. And then we basically copy this, just take it off here. And var r. So this is going to be the road node. Okay. Node at end of at other end of road. Okay. So we're looking at the start road. We're asking how many, or we look at the start node. Then we ask how many rows is the node connected to. If it's one, then we just follow that simple road. If it's more than one, then we look at each road, and then we get the node at the other road, and then now we're going to say if e is equal to 0, because the first time around we're just going to do it, or smallest value or point distance. I gotta think straight. End node, yeah. Okay, so Actually we start by saying uh, target distance is equal to, like so. So we have a target distance, and then we say or point this point distance is smaller than the target distance. And actually, so we're going to say var date. I know we just make a bunch of letters up here. That's not good practice. And the distance is also smaller than the smallest value. And then we just say then we set these two. So we're asking are the not at the end of at the other end of the row, right? So we're asking is the road pointing to a place that is closer to our situation, right? And then it's just smallest index is equal to I, smallest value is equal to D. Okay? So now we're not doing we're not putting in the randomness yet. But then for every time, then we just say, um, so now we say for each road, let me put this out here so it's easy to read. Between two nodes to the target. If roads is equal to, yeah. So of course we don't want to go in the opposite direction of where we're going, and we don't want to choose. We want to choose the one that has the smallest. So wait a minute. Yeah, exactly. This is exactly what we want to do. Okay, so now we have found the smallest value and the smallest ID. So now we can choose. So we can actually just do like this var uh, uh, rest is equal to this, and then every time we say rest is equal to rn, I believe. That has to be the node on the other end of the so the rest, and so then in the final end of this, else if this, and then here return res. Okay, let's see here. Actually, before we do anything, let's take a break. Okay. All right. There we go. So now we're back in it. And so let's just see what happens now. Just give me one more second, please. All right, there we go. So let's go in the let's try and see if this works. So what we can do, we can just build one row here, and then we can see what happens. So it's going. Okay. In line 12. Thank you. Let's see here again. I might very well have done something wrong. Node has rows. When we create rows, we add them. Yeah, you can see here we do that every time. Okay, so actually what we will do now is we will go here. We will go here. So here we draw like this yellow circle. But what we'll do instead is we will say node draw self, and then we'll draw text uh, minus. We just want to see if everything is the way it's supposed to be here. Which is, oh, of course. Yeah, whoop, whoop. There we go. Awesome, it looks great. Let's just keep this for now, doesn't matter. All right, so this, so now we have the node, everything's fine there. Let's see here. So now some people will come in. He's gonna do the go to this one. Now he is not happy. So in line 12 in the script, do this. Yeah. Unable to find instance. Really? But it just says that's it's very interesting. A node has a list of roads, and a road has a list of nodes because they're connected to each other. That makes perfect sense. Oh, let me just kind of, yes, there we go. I think maybe I wanted to say it was weird. Um, Let me just try one more time. Let's see. So goes to the thing and then an error again. So it is able to find, the road. Yeah. What the hell? So we're looking at the road and we're looking at the node of the road. But we should be perfectly capable of doing that, right? So really don't get it. So for each road, perhaps I have a feeling that this happens because of when I make these houses, I might not put in, the proper braking, everything. It is possible. It's definitely possible to do that. I've done it here in this case. Hmm. So let's see here. So if I go into the house builder here, let's just separate them here. You have the road builder and the house builder. So for the road builder, we can do all kinds of things. We can build all kinds of roads, but for the house builder, we have to split a road every time, right? Into two new segments. And that's fine. And so, I wonder. Yeah, so this is because here we need to create four segments. I'm gonna write that. Create four new road segments. Two from split road and new segments. So let me try and run this in debug mode. And then just try and build a road. Okay, good. Yeah. So we have two different nodes here that is put on here, that everything is fine there. Then if I try to split, now we have, yeah, okay. So what happened? So now we can see the frozen situation. That'd be cool. Doesn't matter. Go to targets and instance of option outcome. Uh, so let's just go back to look here. Pedestrian. So it okay, so it has a current node. It's referring to this. Great. Here we look at this one. I mean, it doesn't matter, right? It should work. It should be pretty good. Okay. So let's try again. Let's just see again exactly. It was here. The issue's happening. Perhaps something goes wrong in here. So it splits the road. It removes the road, the old road. It makes a new one. Right. But yeah, what I'm afraid of is that it doesn't. Let's go in here. Here, create a new road. Create two new roads. We create two new roads. Or yeah, in the split function, right? We have the split in here, and then we have the. Let me just do that again that I did before. So what was it that I did? Isn't this in the? There we go. Yeah. So there we see here this road, this node there, the node in the middle there. It's not getting connected properly. I see. And that's very, let's see, click on this action road builder. Okay, great. So when we create the splitting node, let's see here, let's see, it's a section node, this one here. Yeah, we never, with, I think that should have an insight. with splitting node, uh, dot array push rows first segment, second segment. I think that might have been the issue. Yes, exactly. Okay, and it just doesn't do it. Or what? Why does it not do it for the other one? Ah, yeah, exactly. Okay, so when we do the, and we have to do that as well when we are making the house. So we're doing the split rows. Uh, yeah, we just have to do it here, I think. Think this is so it. We're not using this. Wait, wait. Oh, it's the house node. It's not this. It's the house node that's not getting properly. Yeah, there we go. Okay, now we created a house here. Let's see. It's going. It's the same issue. Hmm. Hmm. So let me see. Actually, let me try and run it in debug mode. I'm just curious to see if we can actually catch anything with that. So this is the node here. This is not there. So the error is happening, and I assume it stopped. And it's probably something to do with the way I'm addressing the rows. But no, okay. Let me see. Okay, I don't know what I'm doing. Okay, so, but did this ever work? I'm not sure. This should be the correct implementation, but it's probably not. So, so, so what is happening here? Let's just see what's gonna happen here before I lose all my faith. So it's referring to the instance. Yeah. So this instance here, and then it says there's no instance there. Okay, so let's try and run the debug mode again. And then at the time we get the message, you can see what it looks like there. All right, so here we go. There is this one that apparently does not exist. So it's referring to an old road, you would probably guess, right? And that's the problem. So the nodes, I see. That makes a lot of sense. So the road that is accessing it does not exist anymore because it was destroyed. Um, and so there is a place where question is if it's in here. So we're removing these, okay? I think we failed to remove. So when a yeah, then it destroys here. But it does. So when the road is destroyed, it destroys its lanes, but it does not destroy the nodes. Right. And so when after that, yeah, so after that, when we get the new nodes, so we have to remove. Uh, uh, isn't it like a remove function or something? Yeah. Okay. Delete. Okay. Um, oh. Oh. There we go. And I guess we just have to do that for both of them. Both, so the nodes of the roads that explain, we remove the old ones. Yeah. And I guess, and I think I want to do that before I, so we're gonna write it, remove rows from nodes. Maybe a bit vague. Then create new segments for old road. Yeah, yeah. So we caught the culprit. Let's see if oh, we still fail to, and I believe mirrors will come down for different reason. Yes. So we are not adding the roads back in to the new nodes. Uh, So let's say node 0 is equal to, so now we can refer to them directly. I think this should be enough to undefined. Well, so every road has two nodes, so now we're doing it like this instead. I believe this should be okay. I hope that, because I mean these are references, right? But it should refer to an actual object. Um, all right, so and so when we create, yeah. So my question is again, can I? Oh, it's right here. So when okay, so this the problem is that we're making, yeah, okay. So the road is create road functions strictly. Is there like a strictly creates road and lane instances, not nodes, right? Yeah, exactly. So that's very important to determine, yeah, to distinguish how we are doing this. Okay, so that means that when we create this row here, we have to push them to these. Okay, and, and so we create the new segments, and then we push the first segment to the. Okay, I believe right now the ordering does not matter. So push rows first segment, and with the other one is the second segment. And I believe that should solve everything. I'm curious if this certainly works. Oh, oh. Well, I think that's as good a time as any to stop for today. Let me just try and put a couple more here and see what they. I mean, there's surely something like not right in our calculations here, but at least we have some people moving around now. I guess. I mean, can I do? I guess it's because of the way we're handling. I think if the sub-target and the target become the same, then there's a problem. Let me just see real quick. So the find new sub-target should be able to return the target itself, if that's the best one, right? So actually, what we can do here actually is road. Oh wait, for each road. Okay, let's see. So it does this now, right? What we also want to see is but it's interesting when it then comes to the. We can actually, I think what we can do here is say if RL is equal to end node, return end node, and then just stop immediately. If the end node is like the can be a sub target, then that's just fine, right? So let me just see out of curiosity how this would work. And, and let me just do put a couple more here. Could argue that it's problematic to have these nodes. Hmm, yeah. Well, I tried. I think this is a pretty good time to stop for today. Thank you for participating. It's been a long stream today. It was a lot of fun, and we actually got somewhere, which surprised me too. So take care. Thank you for watching. I'll see you guys next time.